Hello everyone. In this video, we are going to see the topic on Naïve Bayes classifier. That is a supervised learning algorithm. So what is that Naïve Bayes classifier is done means? So it is used the formula of Bayes theorem. It use the Bayes theorem concept and find the classification of whether the particular input data is classified based upon the label or not. So, for example, we have one thing. So we have an individual decision making and group decision making. So based upon that, we have to classify that which one is an individual, which one is a group decision making. So how we can classify is based upon the probability and group decision making based. It is a very challenging one. So we can to calculate the outcome of together. So these are all the use cases are used in that Naïve Bayes classification. So before going into that Naïve Bayes classifier, first we should understand the classification problems in real world scenarios. So the classification problems are, we have the email spam detections, medical diagnosis and sentimental analysis, and also the document categorizations. So these are all the real world scenarios uses the Naïve Bayes classifier in terms of classification of the new input. So in the Naïve Bayes classifier uses the Bayes theorem. So what is the Bayes theorem means? Based upon the prior probability of particular event, it should calculate the posterior probability of the particular event. So based upon the prior knowledge and the evidence, it can find out the posterior probability of the new event. That is the main concept behind the Bayes theorem. So what is the Naïve? So the Naïve states that all the features are independent to each other. So the classification challenge in Naïve Bayes is that we have to predict the class labels and we have to handle the probability and how to use the Bayes theorem. These are all the challenges based in the Naïve Bayes classifier. So the Naïve Bayes classifier processes is, first we should collect the data. So we can gather and organize the data from either the data set or that already existing data set or the new creating data set. So after collecting the data, we are going to find or extract the features. So identify the relevant features from the particular data. So next step is we have to calculate the probability of each features. So the probability calculation is based upon that. So what is the occurrences of total number of occurrences, and a particular number of occurrences is based upon the class labels. Next thing, after calculating the probability, we have to apply the Bayes theorem to calculate the posterior probability. So we have to find the prior probability, and after that, using the Bayes theorem, we are going to calculate the posterior probability. Finally, we have to classify based upon that calculation of Bayes theorem. So assign the data prior to the most portable classes. This is the process of Naïve Bayes classifier. So what are all the probability methods is that we have the several classification approaches in using the Bayes theorems. So one is the Naïve Bayes classifier and the Gaussian Naïve Bayes and multinomial Naïve Bayes and then polynomial Naïve Bayes. These are all the probabilistic methods in that particular classification approaches. So in that we have to do that Naïve Bayes classifier. So what is the Naïve Bayes classifier means? Already I told that based upon the prior knowledge and evidence of the particular event, we are going to calculate the posterior probability of the particular class label. So the key concept behind the Naïve Bayes is that we have to do the probabilistic classifier and the Bayes theorem foundation. We should know the Bayes theorem foundation and independence assumptions. So we have to know what are all the features and what are all the independent features. So that thing we have to identify. And next thing is we have to find out the conditional probability. So the classifier, for example, we have to find out whether the particular animal is cat or dog based upon that prior probability. So the prior probability and the event occurrences of the particular cat and also the total number of occurrences of the class labels, we have to classify whether the particular probability of the particular cat occurrences. So what is the Bayes theorem. So the Bayes theorem says that the probability of A or B, which is equal to probability of B or A into probability of A divided by probability of B. So we have the prior probability, then likelihood occurrences of each futures, and we have to know the posterior probabilities based upon the evidence. So, what is the implementation steps to find out the Naïve Bayes classifier or building the Naïve Bayes is we have to calculate the prior probabilities first. Next, we have to calculate the likelihood of each futures. Next things we have to apply the Bayes theorem. So, after applying the Bayes theorem, we can get the posterior probability. So, based upon that two probabilities, for example, you have a class label like yes or no means we have to find the probability of yes and probability of no. So based upon that probability percentage, so which probability has the highest percentage, that probability is applied to the new input data. So this is the steps begin the particular Naïve Bayes classifier. So the real world applications in Naïve Bayes classifiers are we are using that span filtering applications and the sentimental analysis applications. So next is that the medical diagnosis. These are all the applications we are using the Naïve Bayes classifier. So we already know the prior probability. So based upon that probability, we can find out the posterior probability. So the advantages of using the Naïve Bayes means it is effectively handling the data and it is a simplicity and speed. So these are all the main advantages of using that particular Naïve Bayes classifier in the classification problems. So it is well work in the small set of data. So I hope that you will understand what is the Naïve Bayes. So the Naïve Bayes classifier uses the Bayes theorem to find the probability of the posterior probability of the particular class label. Based upon the posterior probabilities, we have to classify the new input class label which probability has the highest percentage. So that particular class label is assigned to the new input data. Thank you.